I was asked to do a tutorial on how to handle wire jumbles with zip ties and managed to come up with a pretty cool solution here to make this all work. What's nice about this solution is it is 100% sort of dynamic. It will update itself and whatnot. For instance, if I go grab the zip ties and down to array, I could change this to a matter, 10, and I'm going to get 10 zip ties in there. Now you can see the zip ties are actually crushing the wires together and creating a little bulge where each one of them is, and that updates, as they change. So if I, took that count down to 5, for instance, you can see that it's happening at each one of the zip ties. The cable's, dynamic as well. It's going to, update when you move it. So it's going to be a little slow because there's a fair bit going on under the hood to make this happen. But in this case, they're all laying flat. You can see the wires are dragged over top of each other. That part you may not need whatsoever if you're just doing wires moving through, a computer case, for instance, or something. They're all twisting around. They're look a little kind of natural, that they're a little, spread out, and they've got some noise in them and whatnot. So let's break this all down and have a look at each of the parts. So the base path in this case is really simple. It is just a single path here. And if I turn off show end result with alt tilde, you can see it's just a path with a bunch of knots in it. The next thing is normalized spline, which then is redrawing it with a pile of knots in it. Okay, so that's dynamically happening. And the reason being there is that we want spline overlap to be able to overlap those. And since it's all laying flat, that'll work. Okay, it'll set it up correctly, and it'll overlap them, and you can adjust that. So that's just the path. That's really, really simple. So what do we got going on from there? Let's take a look at the wires next. Wires next are pretty cool. They are just a line. So if you look at the line, it is just a line snapped to the grid in the front viewport, so it goes top to bottom. Okay. And if we look at the pivot, it happens to be in the middle, just something to note. You could move it to the bottom and it would make certain things easier, but I haven't here. I have a normalized spline on there, which once again is now creating a bunch of knots along it. We need enough that it will follow the path correctly. So the next thing too was a noise, and I just threw some subtle noise on there, just to, make sure that the wire wasn't dead straight. And then an array modifier, and the array modifier in this case is rotated the whole thing over 90 degrees. Not quite sure why I did that, but I did. And a bunch of rotation, randomization around the Z in this case, so that what we get from this is something that looks a little more natural. I'll just turn that off and turn the array on. Back to the array, and you can see what I've got is something that's looking a little more natural. The idea being is noise is sort of wonkifying the wires a little bit, and then we're just going to array them around and spin them around with a phyllotaxis, okay, and pick as many wires as you want, essentially. The other thing I've done down here at the very bottom is I've set up a random material ID to be placed on them, so that what you're seeing then is the different color wires. And I'm going through 3 different ones. I got a red, blue, and a black going on here. Whatever colors you happen to need. And the material is dead simple. It's just a multi-sub material that's been applied with my 3 colors in this case. So the next thing is I throw another noise on it. And this noise then is just to sort of wobble it up a little more, but above the array. So after the, first noise in the array, and then a twist, and then it's just being twisted as much as you need. In this case, 4,730 degrees, okay? The reason being is it's, depending on how long your path is how much of that twist you might want on there. And then I'm using a path deform. So the path deform is then deforming it along that path with that path chosen, which is our path object. And we're just putting it along there. Now, when I said the pivot might be better at the bottom, it's only because we had to set the percentage to 50% along the path, because the pivot was in the middle. If it was at the other end, it would do this, like it was down at 0. So that really needs to then get set. again, maybe, you know, you'll see some of my other tutorials where I move the pivot to the bottom, so I don't have to do that. We're going to ignore the skin wrap for the moment. Okay, so I'm going to just turn that off. We'll come back to it. The last one at the top of the stack is just a renderable spline. You know, you probably could have done it down at the you know, bottom level or whatever, but renderable spline I put at the top, and I often use that because I can then instance around that to other things to get the settings I'm looking for, so I get the same settings on each one. So it's just giving them a thickness and everything so that I've got wires to work with. Now let's go over, I'm just going to hide the wires for a sec, and I'm going to go to this one here. And this is a cylinder. So let's skip to the bottom and take a look. So it's a cylinder with a whole bunch of segments in it, okay? Not many around, size 12 in this case, but a whole lot of height segments in it. And that's going to, again, be dependent on the you know, length of the path. I put a noise on it. I don't really know why. I probably don't need that, okay? So it really doesn't need that with what I'm doing there, but it's, you know, it's there. Path deformed again, so it's deformed along the path, okay? And then the neat thing here is to be able to get the wires to compress at each zip tie. This is what I had to use. So this object is here to drive the wires getting thinner where, or, you know, packed together more where the zip ties are. So I have a volume select, and if I go and unhide the zip selector, it is strictly just a cylinder, okay, and sorry, zip selector. It's just a cylinder, okay. And it looks like, you know, I've got a pile of height segments, which I don't need. Maybe that'll speed things up if I take that down. And I'm arraying that around the path again. So in this case, the array is set to spline. If you notice, it's also instanced. So it's an instanced modifier in this case, all right? So you can see it's been arrayed along the path with the amount of zip ties that we want, all right? And the cylinder here, the wire compressor, as I have called it, is using a volume select set to mesh object, and this cylinder is picking it. And then you play with your soft selection, fall off, some pinch and bubble to get the shape that you're looking for, and a push modifier above it. So the push modifier is then doing this. So what we want to do is we actually want to turn off the push modifier while we're setting this up. We don't want it deformed for the zip ties quite yet. We go back then to the wires, and with the wires chosen, you know, we come back to this skin wrap, and what I do then is set up that wire compressor. So essentially I'm choosing the that cylindrical object that's along the path as a skin wrap object. Now, it's just default settings I wrapped it to. And then what you can do is, you know, that'll be turned on. Once that's on and recognize that it's there, then you can turn your push on and control how much you want to compress them. So, you know, you can see that if I change that, I can compress and decompress in spots what I'm looking for, okay, and getting it to work. It looks like it's pressing it here for some reason too, probably because it's within proximity a bit. So you can see that I can actually adjust the amount of compression that's happening there. Now the last trick here is then I'm just going to hide off the that tube. I'm going to hide off the selectors, and we're going to go to the zip ties. So the zip ties are just a circle. And I had to do a little bit of editing on it. So I'm going to turn off the show end result with edit spline. And you can see that I've broken the circle, added a couple of verts, and just added this piece sticking out. Got to be real careful here, trying to get the sort of the you know, pull end of the zip ties to look like it's there was kind of difficult, and took a little bit of playing around. There's no, you know, the boxy piece, the sort of the latch piece that you slide it through, doesn't exist. How close are you getting to it? If you need it that close, make them and apply them by hand, you know. So I use an extrude to give it, you know, some, you know, width to it. If you notice, it has no thickness to it at this stage. And then there's the instanced array that is on the zipped selector pieces. So it's going to follow exactly the same location as those selector items are, and it's placed it everywhere. The conform then is conforming it, and it's conforming it to the wires. I was originally conforming it to the zip compressor thing, but it just still didn't quite look right because they don't match perfectly. But that looks like, you know, a complete mess doing that. You know, I've got it set on shrink wrap with vertex normal in the negative, so it's projecting down from each vertex and achieving this. Now, what I do then is just relax it. You know, and you have to play around with the conform value and get the offset to where you want. And then a shell modifier to give it the thickness so that it has thickness and it looks like it's, you know, a proper zip tie. And so with that, you have effectively the end product, and it's completely procedural, and it can be adjusted at will to make it work the way that you like. I hope you enjoyed that.